Hello, everyone, and welcome back to our series of simulation with R Studio. In today's session, we are going to play a game. Okay, so I'm going to ask you a question which is not easy to answer, but then we'll see how we answer it with simulation. So let me tell you the problem first, and then I will ask you a couple of questions to think about, which is really a very hard question that we didn't cover in this course. Suppose we have a case where, we were giving uh, a class, say, of 20 students, whatever number you pick, a quiz. And when they were done with solving the quiz, you know, the teacher was so tired. He didn't want to grade it. So he said, you know what? I'm going to write the answer on the board, but I'm going to return the papers randomly to students, and I want each student to grade the paper they get. And you say, wait a second, what if I get my paper? I say, okay, you will be the lucky one. You will grade yourself. Of course, you will correct it and, cheat on me and, and it's okay. It's okay. I'm so tired. I really can do it. Of course, I don't mean that. Don't blame me for, how the students would behave. I'm sorry. I didn't mean to say that. That's not good. But anyway, so I want to know the distribution. What's the probability that when I return the papers randomly, I was so lucky nobody get their paper to grade? And what's the probability that only one get it, or two, or three, or four? So how do you do that? So we need to learn how somehow to simulate that scenario that I have 20 papers, let's say they are in order, and then I'm going to shuffle them and return them to the students. So maybe let's assume we have 20 students that have numbers. So student number 1, 2, 3, 4, whatever. So when I collect the papers, I'm going to shuffle them and then read the first paper and give it to student number 1, the second to student number 2, and so on and so forth. Okay, so that's we need to know how to do that in R Studio. Number 2, I need to learn how to find the number of matches every run. And then number 3, I want to create a probability mass function. I say if x equals 0, meaning nobody got their paper, how many times did this happen? How many times only one got it, and so on and so forth. So a probability mass function, which I can calculate the mean and the variance. And then at the end of the day, I say, what distribution do you think this is? Notice we did say the binomial, we did the Poisson, we did the geometric, we talked about the negative binomial. There are many others, but it's one of the stuff we covered. Okay, so try to find out how can I even find out that. So we'll try to learn few tricks here. I'm going to start by cleaning the clean environment. It's already clean. And then I'm going to see how I can create a vector from 1 to 20. I'm not going to write 1, comma 2, comma 3. So the quickest way to do it is to say sequence starts with 1, ends with 20. That's it. Oh, I'm sorry. Yeah, it's that. And then you can count by 2 or 3 by saying comma 2, comma 3, and so on and so forth. Okay. So now if I run that, you see, here is the sequence. But now I don't want it to show. I want to store it in something. So maybe I can say students equal sequence from 1 to 20. So you can see they come in order. After that, I don't want to type students every time. I can say n. And suppose we don't know the number of students. So they were like selected from a file, and I want to say, okay, here is the number of students I have. So I say n equals the length of students. Okay. I'm going to run the simulation, say 10,000 times. So n equals 10,000. I want to store the match. How many matches did I get in every time? So maybe I can call my matrix match. And match is a matrix that has that is full of zeros or NA. Notice we can write it NA. We never did that before, which is, by the way, the default. And I need uppercase N number of rows. I don't need more than one column, so there is no reason to say comma 1. I can leave it like that. I think these are all the variables we need so far. Okay, so now I'm going to run the simulation 10,000 times. So I would have to say for I in 1 through uppercase N, open brace and close brace. Inside, I need to shuffle the 20 numbers. So how do I do that? Very simple. It's called sample. I'm going to sample, and it asks you sample from where. Notice if you were taking random sample, you say R norm. I'm getting it from the normal distribution. R X EXP, getting it from the exponential distribution, and so on and so forth. Here we say sample. So it asks you sample from what distribution? You say, no, no, no. I'm going to sample from students, which are the numbers 1 through 20. Okay, I'm going to sample from students. How many? All of them, N. And after that, it tells you replace. I'm not going to type it. I'm just going to show you what it says. Replace. The default value is that we are going to shuffle without replacement. Meaning, if I'm going to select a paper, hand it to a student. So I'm not going to return it back and shuffle and give it to a different student, right? It doesn't make sense. I cannot give the same paper to more than one student to grade. And maybe I will end up with papers that were not assigned to any student to grade. So I want to say replace equals false. Later, we'll learn why sometimes we need to do replace equals true. But now I don't care. I'm just going to create. So now I have two lists or two vectors. The first one is ordered from 1 to 20. The second one is shuffled. So I need to check to see how many do match. So I'm going to count them. So I create a counter. Let's say count or counter equals 0. 0, not 9. And then I'm going to say for j in 1 through lowercase n. So for these 20, I'm going to check each number. Oh, by the way, I created the sample, but this will show it like the sequence. I have to store it somewhere. So maybe I can say my sample or my data. I store it somewhere, right? Because I need to check in my data how many match. So I can come here and say, if my data, the first element in my data, so I say my data j, meaning the first j will go from 1 to 20. So I say if the first data in j equals j is 1, then there is a match. But if it's not, I'm going to go to the second. If the second entry is 2, there is a match or else. So how do I do that? I say if my data j equals, how do I write equals? No, not like equals count. No, you have to say double equal because that's it's a condition. I want to see if this condition is true. If I say my data of j equals j, it means it's going to take j and let it replace what's in my data j. It's not assignment. It's logical equal. Okay. So if my data of j equals j, what should I do? Count. I would increase count by 1. So count equals count plus 1. RStudio doesn't use count plus equals one, like other language. So you have to type it, for example, count equals count plus one. So now at the end of this inner for loop, it's gonna tell me, okay, I found three batches. So what do? I go outside of the first for loop, the inner for loop, and say what? Notice I created a matrix called match. So I'm going to say, but now I have to say match of I, because I am in the first simulation. I counted all 20, I stored them in match. So match I equals count. And that's it. I'm done. I'm done with the simulation. The only thing now I will end up with a column full of 10,000 data points. That's not what I wanted. I want to tally those, combine them, and take away a probability mass function. Okay? It's a frequency table, so to speak. It's not a PMF. PMF has the probabilities that they have their sum. I can create it like that, but basically what I'm going to say is I can create the table right away, and I say table match. So take match and tabulate it. If you want, I could have stored that somewhere. I could have stored that and then divided the table itself by 10,000 to get it as probability. But I think that's enough. Okay, that's enough. So let's run the simulation and see. Wow. Okay, look at that. I ran the simulation 10,000 times. I got 3,539, like 35% of the time, nobody got their paper. And roughly 38%, only one lucky student got it. And you can see that out of 10,000, I only get two. That two had them 603, 156, 39, 62. Okay. So that tells me that roughly this is like 38 and 35. That's 73 of the percent of the time, like 3/4 of the time. So if I do it 4 days in a row, 3 days, only at most I will get one student getting their paper back to grade it. And 1/3 of the time I may get two, three, four with a decreasing count. But I, I ask you a question. How can I check to see, or how do I at least guess what distribution that is? Of course you can. So let's try to make it easier. Let's say find the mean of match and maybe the variance of match. Let's run it again. Of course, the numbers will change because I didn't set a seed. This time I got, again, roughly 73% had at most one. You see, the numbers are almost the same, very, very, very close to each other. But now I have the mean is roughly one and the variance is roughly one. What distribution did we learn that the mean equals the variance? Scratch your head. Huh? Yes. The Poisson distribution. This one has a mean of one and has the variance equals the mean. And that's the distribution that has the mean equals the variance is the Poisson distribution. And it turns out that this problem, the solution to this problem is Poisson 1 with a mean of 1. Okay, I hope this was a funny way to do it. It's a nice simulation of something that is not engineering, is not math, it's maybe a trivia. And I ask you, how likely do you think, or how many students do you expect they get their paper back? And you would say like 73% of the time, at most one. Sometimes like half the time, like 37% nobody will get it, and 36% one So roughly 3/4 of the time. Okay, I hope you enjoyed this one. The next simulation probably will start going into bootstrap simulation that you can do with directly with the with a specific package. But I would show you how to create it yourself to be more flexible. You can do whatever you want, not relying on some packages. It's easy, and it would be very similar to what we do here. Similar, not exact, but we'll see how you like it. Okay. Thank you for your time, and I hope to see you again soon.